Welcome to part 3 of Competency 7. In this video, we will answer questions relating to asymptotes of rational functions. We're still working with rational functions. However, we need to concern ourselves with the denominator and the restrictions associated with the denominator, not necessarily for the domain. But those restrictions, they actually give us the vertical asymptote for the rational function. Number 1, what are the vertical asymptotes for the function f of x? This is the same function we had in the prior video. And again, we will look at the denominator because we are looking for this vertical asymptote, which is the same thing as what we didn't want x to equal when we asked about the domain. So that means that x is going to equal 2/3. So the only option we have is B. If you remember in the prior video, we said it cannot be equal to 2/3 because we were looking for the domain. In this situation, we actually need to identify that line. Okay, let's go to number 2. Okay, for number 2, the situation's a little different. Yes, we will still look for the domain, and we're looking for those values of x. Okay, we will have, though, instead of 1, we have 1, 2, 3 situations. However, the first one, when we solve that, it's very easy to see that x will be equal to 0. When we solve the last one, it's not difficult to see that x is equal to -7/3. It's this middle one. Let me come down here. I'll even change colors. We have x squared, okay, and that'll be equal to -4. Well, you probably already see what's happening. When we put those under the square root to solve for our x, we get positive -2i. Okay, that's a complex situation which we do not consider for our asymptote. So that isn't even in the running. So what do we have left? We have our 0 and our -7/3. And option A is the only thing that works. B, I needed 2 real zeros. They're actually not zeros. They'd be values of x that are a break in the graph. Our line of our graph will become very close to 0, and it'll become very, very close to -7/3 without ever touching it. Now, D, we know we cannot accept that because it has those two complex situations. Next, we will examine the horizontal asymptote of a rational function, and we looked at the leading term of the numerator and the denominator. We call that exponent that we're first looking at, and for the numerator and for the denominator, we call it m. Okay, and also notice before I begin discussing it, A and B are leading coefficients. Okay, so we look to see if m equals m. If m and m are the same, they're the same value, they equal, okay, then the horizontal asymptote is just a ratio of those two leading coefficients, A and B. And that's what's written out, y equals A over B. And then if n is less than m, then the horizontal asymptote is just 0. Now, if n is greater, if the exponent of the leading term of the numerator is larger, then there just simply isn't a horizontal asymptote. Number 3, what are the horizontal asymptotes for the function f of x? And as we just said before, we look at the leading terms and their exponents. Well, what do we have? We have n is equal to m, which equals 2. And in this case, that's the first condition. So we have y equals a over b. Well, that will be 1 over 3. So option B. And that eliminates a because y isn't equal to 1. It's 1 over 1/3, 1 over 3. And that gets rid of our 0 and our d. Okay. Number 4. What are the horizontal asymptotes for the function f of x? Okay, again, same thing. We need to look at those leading terms. And in this case, n, which is 4, we have 4 is less than 5. Well, that means that y has to equal 0. Okay? And if we look at b, you can't use the exponents to get your value of y. That won't get you your asymptote. So that doesn't work. And because m and n aren't equal, then we can't say 2 over 1. So that's also eliminated. Okay? And that in itself gets rid of d also. Number 5, what are the horizontal asymptotes of the function r of x? Okay, for this function, same thing. We need to look at our leading terms. Well, we see that 6 is greater than 3. Well, when n is greater than m, this means that there is no asymptote. And when we go to look at our function, I have it already put into our calculator so we can graph it. It's unusual looking, and we can kind of see where that would be the case. We have an idea of that. So if we zoom in a little more, we can kind of see that. Probably don't have one. Okay, but regardless of what your calculator does for you, shows you, you can trust this fact that our exponents of our leading terms are going to determine the fact that there's no horizontal asymptote. Okay, let's go to number 6. What are the horizontal asymptotes for this function f of x? Okay, same thing. Let's look at our leading terms. Oh, well, we're going to have to come up with what our leading terms are. Let's look at that. Let's see. I see 1, 2, 3. Well, I'm going to let's take all of these first x terms, multiply them together, and that'll give us what we need. Okay, well, that's 2 times 3 is 6. Okay, we have our x. 1, 2, 3 to the third. Now, let's go to our denominator, and we're looking at x squared into x. And this gives us 2x to the third. So we're looking at n equals m equals 3. So since they're equal, this means that we need to look at our leading coefficients. So that means y equals 6 over 2, and that actually gives us 3 again. So A is the option that we need. Next, we're going to look at the oblique asymptote, and how we find that is we look at 2 conditions. The first one is if the exponent in our numerator, the leading term in our numerator is just one more than the exponent of the leading term in the denominator, that would be that n has to equal n plus 1. Then we know we have an oblique asymptote. And how do we find that? We just use long division. Now, if we have a remainder of 0 after we go through that long division, then we know we don't have an oblique or slanted asymptote. Number 7, what is the equation of the oblique or slanted asymptotes of the function g of x? Okay, so first we need to look at our exponents of our leading terms, and 3 is one more than 2, so we know that we actually do have a slanted asymptote. So let's go ahead and solve that. So we have x squared minus 2, and that is squared. Okay, then we have negative 3x to the third plus 2x squared plus x minus the 6. Okay, I won't go through all the steps in detail, but the name of the game is to match the negative 3x, the first term. What do we need? We need a minus 3x. So we multiply that out. So let's go ahead and do this. When we multiply that out, we'll match it, minus 3x to the third. But we're subtracting. So the minus becomes a plus. Okay. Now, when we multiply that to this negative 2, like would do in any division, long division, we see that we have a plus 6x. First off, we don't have anything to put with the x squared, so we skip it. And now we put minus 6x. Why? Because we're subtracting the positive 6x. So now it's minus, okay? So what does this do for us? Well, the first terms become 0. The next term, we just bring it down to 2x squared. Now, plus 1x minus 6x is minus 5x. And we bring down the minus 6. Okay, then we need to say, okay, what do we need to do to get 2x squared? Well, we need a plus 2. So that gives us 2x squared. Well, we're subtracting it, so we use the opposite sign so we can subtract. And now 2 times negative 2 is negative 4, but that's a plus 4. So we put our plus 4 here. Notice that we don't have anything to pair up with our minus 5x, so that's just plus 0, little placeholder. So the first terms, they become 0. So now we have minus 5x minus 2, and that will be our remainder. So we did need a remainder, so check mark on that. And that means our equation is our quotient, the minus 3x plus 2. Okay, and that's right here. And this means that B is our option. Now, don't be misled by A, because that's our remainder. And our remainder isn't going to give us that slant that we need. Okay, this just gives us the remainder if we want to solve out the problem. Number 8, what is the equation of the oblique or slant asymptotes of the function f of x? Okay, Well, this means we're going to have to work out long division again. Okay, so we have 2x minus 1. Divide that all into 10x squared plus 9x minus 7. Okay, the first term is 10x squared. So what do we need? We need 5x to multiply to get that. So that means we have a minus 10x squared and a negative 1 times a 5x. Well, that's a negative 5, but we're subtracting, so we make that a plus 5. The first term becomes 0, and that means the next term is plus 14x minus 7 is brought down. Now, what do we do now to get the 14x? Well, we have 2x, so we just need plus 7. But when we multiply that, we're subtracting, so that's minus 14x. And then 7 times a negative 1 is a negative 7, but we are subtracting, so we use the opposite sign, and our remainder becomes 0. And if you remember from one of the conditions, we cannot have a remainder of 0. So this guy right here tells us that option D is what we need. There is no slanted asymptotes in this situation. Okay, so the other three options are not what we're looking for. Okay, and that'll be the last problem in this video. I want to say thank you very much for watching. If these videos are helping, please consider subscribing if you haven't already, or share us with a friend, or like us if you think we've done a good job. And remember, happy testing.